Today I'm going to discuss on how we can move beyond purification to engineer smarter and clean air ecosystems. Moving forward, we all know as of now, the clean air is just not a environmental challenge. It directly affects not only the health, productivity, compliances, and sustainability, but also the cognitive productivity and ultimately the mental health. So, if we are breathing the clean air, we could be more productive. That for the commercial aspect, that will be very, very important to be very productive. We can say that this is not an environmental issue, but a socio-economical issue. As it is moving beyond just the environmental issue, we need to provide the clean air in very effective manner. But to provide that particular clean air, we have to engineer the solution. So we know in the market there are already multiple technologies available. So we can list down all these technologies, majorly consisting filtrations, electrostatic precipitators, scrubbers, ionization, and so on. But the each system has their own sets of advantages and disadvantages. So this is not something new. This all has been there in the literature since several decades. We all know the options are available, but the choice of selecting particular one technology for addressing one issue is very important. So it is not very difficult to have the technology. It is very difficult to engineer this technology. So I'm going to discuss about what are the different technologies available and how our approach should be to select those such technologies available in the market. So moving forward, I have a framework. So I have divided the framework into the three part. So if we talk about the chain of particulate matter mitigation, it start with the generation of particulate matter. So, whenever any kind of process that emits the particulate matter, it provides the particulate matter source. Once it is emitted into the environment, it is then available into the environment and goes to the exposure. Based on the continuing this cycle, I have divided this framework into the three parts that can be a source mitigation, source control, and the exposure control. So, if we talk about the source mitigation, it's the simple prevention of generation of the pollutant. So, if you talk about any process, for example, any process that is involving the generation of that particular pollutant, be any industrial process or any household process, we can replace the energy utilization. For example, we can use solar energy instead of electrical energy. So in the electrical energy production, coal is burned. During the coal burning, we can see that many of particulate matter, particularly the black carbon, is emitted into the environment. But if we could just replace those source to the solar energy or the renewable energies, that can prevent the formation of this pollutant. That can be a source mitigation. But in many applications, we can see this is not possible. Anyhow, how hard you try, you are going to generate the particulate matter. Then there comes a second layer, that is source control. So if you just say one example, like my tap is running out or having some leak, so cutting down the liquid supply will be my source mitigation, where I completely avoided that particular leakage. But now I have to run that particular tap without harming the process, because water is the necessity, everyone wants it. So there comes a second level. Now I know that pollution has been done. So we will have some principles, we will employ that on the source and avoid the exposure to the environment, so that this pollutant are mitigated before it in getting exposed to the population. Continuing to the same example of the leaking tap, we can just say that just cutting down water is not possible here, so we have taken one bucket and kept it under the tap. So whatever leakage is there, we tried to control, that is not spreading into the room. But there comes a situation where even these processes are not possible, and it is going to the environment, and there comes the exposure control, where we can see the indoor air filtration, HVAC system, HEPA filtration, where population is already exposed to this particulate matter, and as it is exposed, indoor environment needs to be clean. So continuing to the leaking tap example, we can say now the water has been spread into the room, so we have to wear the leak proof shoes. So this is what about the strategic framework. Once we know that we have to act on particular one level like source control, source mitigation, or exposure control, our approach or the engineering this particular solution will goes to different face to different challenges, as well as the approach will going to change. So let's discuss about one of these approaches. So where you act determines your impact. The earlier you act, earlier you intervene to this particulate matter mitigation chain, more will be the impact. For example, we can say, so we have identified in Novorbisitis, we have identified a diesel generator as one of the polluting source. So we can see in hospitals, in residential settings, in industries, everywhere power is essential. And to running this smoothly, we have to maintain the power, even though there is a power cut by the suppliers. So to mitigate that, there is a diesel generator, but this diesel generator produces lots of SOx, NOx, and particulate matter. This particulate matter is directly impacting our environment and as well as our surroundings. So to mitigate that, we have to provide the source control. Here, source mitigation is not possible. We cannot change the fuel. Whatever we can do is we can just have add some additives to prevent the pollution control, but it is not 100% possible. So that we come up with the idea that we can change this thing by a source control. So how does that affect the environment, indoor environment? So we know that the majority of the pollution sources are outdoor. There are indoor sources, but if we look for the contribution of the sources, we can see that the major contributions come from the outdoor. So the pollution source pollute the environment, particularly the outdoor sources, and our indoor sources are continuously directly in contact with this environment. And this ultimately affect us because human exposure is majorly 90% of our time we spent indoor, but our indoor air is taken from outdoor. So directly or indirectly, we are getting exposed to these pollutions. And therefore, our approach is not only look towards indoor environment, but for also the outdoor as well, nearby our residential settings and our corporate settings. So we all know that each of the settings sector in different sectors have different types of aerosols. Healthcare facilities were morely focused about bio aerosols, whereas commercial and office buildings will morely look towards the particulate PM 2.5 and PM 10. Different industrial setting will have the different approach based on their type of pollutant, their type of framework that we are going to apply. And to overcome this, I come up with one this case study, that is that we discuss about the diesel generator emissions control. So we can know in many corporate hospitals, industrial plants, everywhere there is a diesel generator. So there are multiple. Now we also discuss about the several technological options. Filter is the most efficient option, but if we look for the particular DG emissions, this is not the practical solutions. So that we have to go for some filterless options, particularly towards electrostatic precipitator and some ionizer based technology. So choosing technology, again engineering it according to this particular sector that we have selected, is a critical challenge. The best emission control system is not one that does not compromise the equipment it is protecting. So wherever we are particularly thinking of a filter based technology for a DG set, it is going to choke all the exhaust gases and creating the back pressure. So selection of this system is very critical, and we have to choose it properly, engineer it properly. Moving forward, so this is one example. If we look around, there are lots of overlooked urban emission sources. One of which is we can see in very urban settings, there is a Hindu crematoriums where lots of particulate matter is generated, and the buildings surrounded directly or indirectly are getting affected because of this particulate matter generated. And therefore we come up with an approach that small filtration or simple electrostatic units are not going to work here. Therefore there are some hybrid approach needs to be acquired, and for this we have a cyclone separator, which take care of the big particles, particularly in the range of PM10. And then for PM2.5 and PM1, we have an electrostatic precipitator. Combining both these technologies in providing synergistic effect, we are come up with a crematorium air purification control devices, and it is currently installed in Mumbai and serving it. So I just wanted to convey a message that we have available multiple technologies, but engineering them according to the particular application is the critical challenge that we need to identify. So this is just an illustration of electrostatic precipitator, that how we manufacture the electrostatic precipitator. So we can see these are the very compact devices, and very small spaces we can deliver all this electrostatic precipitator principle for controlling PM 2.5. This is again one of our product for carbon free advanced catalyst for converting your carbon monoxides and particulate matter into clean air. So what are the future trend? Talking about the technologies, we know that multiple, now we come up with the framework that technologies we know which technologies we need to choose. But even after choosing a particular technology, there comes a challenge. Now world is evolving very fast. We have to be predictive. So there must be a IoT based control system which is continuously tracking your data, AI driven predictive maintenance. So whether any device is going to face any kind of issues into the future, that is going to be addressed before. So if you know what is going to happen in future, we can try to prevent that. So that is one basic thing. Again, we have to provide the hybridized approach, multiplying this all technologies available. So this is about the future trend in clean air. And we know that for building and clean air ecosystem, single principle is not going to work. So we have to come up with all things, that source control, smart monitoring, HVAC system, ventilations, energy optimizations, everything we have to come up in a single system, so that it will act as an ecosystem and provide the clean air. If this clean air is available into the corporate setting, it is going to boost your productivity, and it is going to not only provide you the environmental as well as the health impacts, but also will help you to generate revenue. So entrepreneurs has to be think it not just an environmental compliance, but as an investment for your future future upgradation of your businesses. So, actionable takeaways from my presentation, I would like to conclude here is that whenever we want to address any issue, we have to audit before we engineer. We have to think in layer. We have not to limit ourselves to the single particular technology. Measure, monitor, and manage continuously, upgrade our systems, and align with indoor air quality with organization goal. So, we should not treat clean air as just a commercial environmental protection, but also for a business development thing.